So moving on to section 2 in chapter 11, we're looking at the diagonals of a polygon. So last section we talked about the general shape of a polygon, the names for them depending on how many sides they had, and also if it's a convex or a concave polygon. So now we're going to be looking at exactly the diagonals of a polygon. So the diagonals of a polygon are the lines that I drew. If you remember convex or concave, those were the lines that I drew within the polygon. So here you see my polygon is the pentagon. Okay, it's the outside shape. But if I draw my lines from one vertice to the next, okay, that's creating my diagonals. Okay, so they are segments that go from one vertice to another that are not sides of a polygon. Okay, so that's what the diagonals are. So if we look at these shapes, so I've got triangle, I've got a quadrilateral, I've got a pentagon and hexagon, and we want to draw the diagonals. Okay, so I can give you guys, if you want to stop this video, you can draw these shapes and then draw the diagonals for yourself, and you can see what the answers are. Okay, so looking at this, the triangle, which is our first shape over here, if we want to try to find the diagonals of it, okay, as you notice, we got to go from one vertice to another, but we can't include the sides of it. And as you notice, you can't draw a diagonal in that triangle. So that triangle is just going to be 0. So there's no diagonals in that triangle. If you move on to the quadrilateral, so the shape down here, if we want to draw the diagonals, we can start from this point and go across. There's 1, and this point, go across, and there's 2. So now I have 2 diagonals for it. Okay, going up to the pentagon, we saw last on the previous slide. So as you see, it kind of makes a little star within it. Okay, and so that gives you 1, 2, 3, 4, 5. So it gives you 5. Okay, same as the amount on that one. So now we move on to the hexagon, and the hexagon gives us 1, 2, 3, 4, 5, 6. 7, 8, 9. So you see the hexagon gave us 9 sides. Okay, so as you see, we went from 0 to 2 to 5 to 9. Okay, I think 9. Yeah. So now what we have is we take our sides. Okay, so to find how many diagonals we're going to have, we end up using this formula. Diagonals, D, is equal to 1/2 n times n minus 3. So however many sides you have, that's the n. So looking at our hexagon. So our hexagon has 6 sides. Okay, so that means we would go 1/2 times 6 times 6 minus 3. Okay, times 6 minus 3. So that would be 1/2 times 6, 3, times 3, which is 9, which is how many we said we had. So if you simplify it, you get it down. So going to these problems, okay, take a minute, find how many diagonals you should have for each one of these. Okay. So the first one with a decagon, okay, we'd end up taking 10, that's how many sides a decagon has, so 10 times 10 minus 3, which is 7, divided by 2. So the first one we should get 35. Okay. The second one with 20, we would take 20, we'd multiply that by 20 minus 3, which is 17, and then we divide it by 2, gets us 170. So we end up with 170 for our 20-sided figure. And then 35 ends up getting us about 560. Okay, so about 560 for our 35. So as you see, the larger the shape, the more and more you get for your sides. Okay, so the more diagonals you end up having. So the larger the sides, the more diagonals you end up having. But you just follow that formula to find how many diagonals there would be. Okay, so your homework in that section is 376, numbers 1 through 17. Okay, so make sure you get those done, and then we'll be able to move on more with these polygons.